Okay, we will create the following 3D model using SolidWorks. What we have right here is basically this shape, bear with me, started along this direction. That is pretty much it. We have 1, 2, 3, 4 holes. This nomenclature means that the 4 of them are 200 millimeters each, talking about the diameter. And that is pretty much it, guys. Other nomenclature is this one, 500x 45 degrees. That means that this is like a rectangle. I'm sorry, like a rectangle right here. Right here we have an angle of 45 degrees, and from this point till this other we have 500 millimeters. Right? Why millimeters? Since I cannot find any information about the unit system that the engineering draw is using, for example, inches, it could be used customary base units or international system. That is like the two principal unit systems. Then I can assume that these are millimeters. All right? Now, this engineering draw was made by Luis Miguel Huérfano Garzón, and he made some different mistakes along the process of doing this engineering draw. The first one, this is a notation, guys. This means either you are working with views in ISO A or ISO E. Okay, please be aware of that. Now, I'm not going to explain what that means, but you can Google it and you can see actually Google images, and you're going to understand it. Okay, you cannot use both of the notation in the same engineering draw because this is not correct. All right, this is a mistake. Second mistake, please do not place the information like this. There is a normativity, guys. You have to follow it. There is a lot of different normativities, so please be aware of the normativity that you want to use. For example, there is usually a box in which you place the material, the unit system, the tolerances information, everything that the reader needs for he or she to manufacture it, or to create once again the 3D model, for example, the tolerances, right? Now, this is the Spanish for exercise 2, aluminum, steel, copper, but please do not do this. Now, this is the symbol of the education. I just get rid of it, and as well it's important to place the number of the engineering draw if there is more than one. Okay, that means this is Spanish for 2 of 5. Okay, because right here we have several different engineering draws. Alright, now we can begin. Now that I've made that like introduction, I'm not going to show anymore this engineering draw because I think that it is pretty easy to understand. So as well, this is not, well, I'm not going to say that this is incorrect, but please don't do this. Please be aware that you have to manage the notations, the dimensions. For example, if you can, it's not mandatory, but if you can, please place the dimensions outside of the 3D model, right? This is not like pretty well. It is not incorrect, but it is not correct as well. Now, please be aware of this as well. Do not create cross dimensions. This is not well seen as well. And that is pretty much it. Okay, that goes to this dimension, this. Please do not try to not place the dimensions inside of the 3D model, okay, of the view. Please try to place them outside, okay? All right, so that would be pretty much it. We can start. I took 5 minutes of the video for me to show that, so we're going to click on the arrow file new. This is going to be a part, so okay. We're going to click on sketch once again, and I'm going to select the front plane. Now let me see. Yes, I can rotate the view, but I don't like it, so Ctrl 8, and I'm going to disable the rotation. All right, now I'm going to create the general like part. So this is for SolidWorks, it's important for you to take into account the principal dimensions. All right, so for example, this looks something like this. Make sure that everything is like proportional. All right, everything looks good. Now I'm going to start defining the general dimensions. So right here we have one, which is 3000 millimeters. Enter. Right here we have the other, which is 2000. This is 900. So 900, and this is 1000. Now we are going to start creating the circles, the holes, and the what is it called? The straight slots that we have right there. So I'm going to select the circle option. Right here we have one, right here we have the other, right here we have another two that are placed at the same level, the same axis. And now I'm going to deselect this tool, and using the Ctrl key, I'm going to select all four and say that those four circles are equal. Okay, that way when I define the dimension of one of them, the other three are going to take the same dimension. So this is 200. The position with respect of this edge is 200 as well. Sorry, 200. And the same goes here, 200. I don't know why the SolidWorks it's pretty slow when I'm recording the screen, but please bear with me. So this is 200 as well. And right here we have as well 200. Okay, now this is 1000. And with respect of this edge, this is 400. what's left? Okay, with respect of this other, we have 500. Now let me see, because as you can see right here, this circle is in blue. That means that I can move it. Okay, so I'm going to select this and this and see the options. Horizontal. Okay, everything is set. There is remaining the 2 slats. So out here we have the first one, and the other is something like here, dimension. Now with respect of this edge, we have 1000. The radius, or the diameter, okay, the radius is equal to 100. And now what's left is to define escape, shift key press, and select 2 circles. That way we can select the outer part of the circle and not the center point. And this is 1000. What's left? Okay, 500 with respect of this edge. $500, and what's left is this. So the radius is 50. The position with respect of this center point and this other is 500. And finally, the magnitude between the tangent points of this and this is 500. Okay, everything is perfectly defined. Now I'm going to select features, extrude. Okay, and the engineering draw says that the width is 50 millimeters. So 50, enter. Sorry, not 500, it's 50. Okay, and okay. Okay, now I'm going to activate the option for me to rotate the part. And what's left is to create the corners. So basically we have 3 corners of 500 millimeters. With respect of the horizontal line, there is an angle of 45 degrees. So we're going to create this with a chamfer. I just have to select the edges. So this is the first edge. This is the second one. And this is the third one. Now for those 3, we have that there is 500 millimeters and 45 degrees angle. Okay, as you can see, the preview is showing something correct now. Okay, and there is another, which is nope, it's not a fillet, it's a chamfer. which is the one that we have right here. This edge is 200 millimeters with a 45 degrees angle. And that is pretty much it, guys. This is how you can create this 3D model using SolidWorks.